All right, example 1. We're supposed to find the volume and lateral surface area of a square pyramid. The altitude is 10 feet. Okay, first off, when you see the word altitude, the altitude of a pyramid is the length from the very top of the pyramid perpendicular to the base. So typically we draw a dashed line to represent the altitude. So if I'm drawing the altitude, if I come here straight down, why is this not? This board is just determined to upset me here. There we go. If I come straight down and I'm going to draw a right angle here, kind of to a point. So that's what we're looking at. All right. And the other thing, it does say a square pyramid. So if I were to draw a segment to the midpoint of one of the sides, let's just go to this side to give it a, so that's the midpoint. So I'm going to put my right angle actually on this side. All right. So what I know is this piece here is 4 feet because it's going to be kind of, if you imagine a three-dimensional thing going on here, this should be the middle of the square where we hit. Okay, if this is a square pyramid, we come straight down to the middle. So from the middle to the edge should be half the length of the side, right? So 4. So this is a midpoint. And then we have this dimension from here to here that goes from the tip of the pyramid to the midpoint of a side is called the slant height. Okay. So they tell me the altitude is 10 feet, so they tell me that dimension 10 feet. I figure out this dimension is 4 feet because again the altitude comes to the center of the base. So from the center to the center, that's 4 feet across. And the slant height then can be determined by doing the Pythagorean Theorem. So if I call the slant height, let's just call x, give it a name. The slant height is the hypotenuse of this right triangle happening inside this pyramid. So I know that the hypotenuse squared equals one leg squared plus the other leg squared. Right angles happen quite often in pyramids, so the Pythagorean Theorem happens quite often in pyramids. So as soon as you see a pyramid's happening, there's a possibility we'll have to use the Pythagorean Theorem. Okay, 4 squared equals 16, 10 squared equals 100. So x squared equals 116, which means x is going to be the square root of 116, 10 point something. Somebody have a calculator?
10.77.
10.77. Is that rounded correctly?
Yeah, that's under 0.
Okay, perfect. 10.77. So the slant height of this thing is 10.77 feet. All right. Those are the 3 dimensions you need to know. You need to know information about the base, which the base is a square. You need to know the altitude, which is 10 feet, and you need to know the slant height, which is 10.77 feet. All right. Now, with that in mind, let me just bring up these properties here, these formulas. These are on your sheet over to the right of the example 1 box. This same information is on your sheet. These formulas are what we're going to use to do whatever we need to do. So this problem specifically asks us for the volume. So the volume is 1/3 AH, where A is the area of the base and H is the altitude. And the other thing they're asking us for is lateral surface area. Lateral surface area is right here. That's 1/2 PS, where P is the perimeter of the base and S is the slant height of the lateral face. Right, so we have 2 formulas, we have things defined, and if we identify what we know already and then find what we don't know, we can go ahead and get this done. So, can everybody agree that the slant height is equal to 10.77 feet? Notice over here I called it X, but the formula uses the letter S, so I'm going to call it S. P I don't know yet, A I don't know yet, H is equal to 10 feet. 10 feet is the altitude, which is given to me right there, altitude is 10 feet. So the slant height and the altitude are both just linear dimensions. Some number of feet, some number of inches, yards, miles, meters, whatever. All right? The perimeter and area come from the base, perimeter of the base, area of the base. So the base itself is this square, which is an 8 foot by 8 foot square. So if I look at that, you just take this, shoot, take this and shrink it up. This board. Here we go. So if I draw the base, which is a square, the base dimensions are 8 feet by 8 feet. How do you find the area of a square?
Length times width.
Length times width or side squared, take your pick. 8 times 8 is 64, right? So A is going to be 64 square feet. How do you find the perimeter of a square?
All the sides.
Add all the sides up, and squares, all sides are equal, right? So this is also 8 feet, this is also 8 feet. So 8 plus 8 plus 8 plus 8, or for specifically for square, you can do 8 times 4. Either way, it's 32 feet. So over here, you have the formulas, you have what you need to know, right? For whatever you're asked for. In this case, lateral surface area volume. They didn't ask us for total surface area, we don't need that formula. And what you are trying to evaluate, it tells you what variables are important, which is right here. So it's your task to go through the problem and search it out. And then apply the correct formula to get the correct answer. So the volume, the first thing they asked for, the volume is equal to A times H. Well, in this case, A is 64 square feet. H is 10 feet. And if I'm multiplying square feet times feet, that makes cubic feet. The correct unit for volume is 64 times 10 is 640. Okay. The lateral surface area in green there, the formula is 1/2 PS. 1/2 P is 32, and S is 10.77. 1/2 times 32 times 10.77. It's just a multiplication, one times the other times the other. So first number half times second number 32 times third number 10.77, 172.32. This is 32 feet and 10.77 feet. Feet times feet create a unit of feet squared, the correct unit for a surface area. So the lateral surface area is 172.32. The volume is equal to 640 feet cubed. I said cubed, I wrote squared, sorry. 640 cubic feet for the volume, 172.32 square feet for the lateral surface area. And again, those are the formulas for pyramids. That's how you do it. It's your job to find all the information here using your knowledge of math that we've dealt with so far.